Welcome to the first video in our MCAT General Chemistry series. Today, we're diving into the very foundation of chemistry, the atomic structure. Understanding atoms is crucial because they are the building blocks of matter, and mastering this concept will set you up for success in all areas of chemistry. Let's get started. The concept of the atom has evolved over time, with different models helping us understand the complex nature of atomic structure. Dalton proposed that atoms are indivisible particles, each element consisting of identical atoms. While this was a groundbreaking idea, we now know that atoms are made of smaller subatomic particles. Thomson discovered the electron and proposed the plum pudding model, where electrons were scattered within a positively charged pudding. This model didn't last long, but it was a step forward. Ernest Rutherford, through his gold foil experiment, discovered the nucleus, a small, dense, positively charged core at the center of the atom, surrounded by electrons. Niels Bohr introduced the idea of quantized energy levels, where electrons orbit the nucleus in fixed paths. This model is closer to what we understand today, but still not entirely accurate. While the Bohr model introduced the idea of quantized orbits, we now understand that electrons do not move in fixed paths. Instead, they occupy orbitals, regions of space where they are most likely to be found. The modern view of the atom is the electron cloud model, where electrons exist in probabilistic clouds around the nucleus, rather than fixed orbits. To truly grasp atomic structure, we need to understand quantum mechanics. The behavior of electrons is described by quantum numbers, which help us determine where an electron is likely to be found. First is the principal quantum number, or n. This number indicates the energy level of an electron and is always a positive integer. As n increases, the electron is further from the nucleus and has higher energy. With the exception of the d and f orbitals, the shell number matches the row of the periodic table. Next, the angular momentum quantum number, or L, defines the shape of the electron's orbital. It ranges from 0 to n-1. The shapes correspond to the letters S, P, D, and F. An L value of 0 corresponds to the S orbital, 1 corresponds to the P orbital, and so on. Next is the magnetic quantum number, or M sub L. This number describes the orientation of the orbital in space, with possible values ranging from negative L to positive L. Lastly is the spin number. Electrons have an intrinsic spin, which can be either positive 1/2 or negative 1/2. This property explains why two electrons can occupy the same orbital. They must have opposite spins. Together, these quantum numbers provide a unique address for each electron in an atom. Electron configurations describe the arrangement of electrons in an atom's orbitals. They follow the Aufbau principle, Pauli exclusion principle, and Hund's rule. The Aufbau principle says that electrons fill the lowest energy orbitals first. You can see here how to tell which have the lowest energy by lining up the orbitals as shown and following the red arrows. So this would go 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. The Pauli exclusion principle says that no two electrons can have the same set of 4 quantum numbers, meaning an orbital can hold only 2 electrons with opposite spins. This is shown at the bottom of this page, with arrows representing the spin of the electrons in the boxes. You can see that the electrons cannot be spinning the same way. Finally, Hund's rule says that electrons will occupy degenerate orbitals with the same energy, singly before pairing up. This is shown on the right, with each electron getting its own box or section within the orbital until it has to share. Before we wrap up, let's summarize the key points you need to remember for the MCAT. Understand the historical development of atomic models and how each contributed to our current understanding. Know the 4 quantum numbers and their significance in determining electron configuration. Be able to write and interpret electron configurations using the principles of quantum mechanics. Remember that the modern atomic model is based on probability, not fixed orbits. Mastering atomic structure is essential for your success in general chemistry and beyond. This foundation will support you as you tackle more complex topics in chemistry. Stay tuned for our next video, where we'll break down the periodic table and explore its trends.